Hello everyone, and welcome to my poster. Today, I am very excited to present our paper. In analyzing the traditional paradigm in few-shot action recognition, we identified two critical bottlenecks. The first is weak semantic correspondence. Existing prototypes are usually learned through implicit sample interactions without explicit alignment between the query and support pairs. Consequently, their class representativeness is limited. They tend to absorb a massive amount of irrelevant static background noise, leading to severe shortcut learning. The second bottleneck is mechanism incompatibility. The independent design of prototype, learning, and the matching strategy creates an inherent gap between the learned representations and the actual matching mechanisms. To solve these two problems, we propose match-guided prototype learning. Our core philosophy is to use the matching process itself to actively guide the construction of the prototypes. We introduce a pre-match interaction so that the support features are dynamically calibrated by the query video before the final prototype is even formed. To achieve this, our framework relies on two major technical designs. The first is the multi-granularity matching mechanism. We use EMH to compute occurrence video-level similarities as a global semantic anchor. Simultaneously, we use K-match, a fine-grained frame-level mechanism that utilizes attention to extract only the most relevant action frames while filtering out redundant background frames. The second major design is our cross-shot attention aggregator. When fusing scarce samples, the variance in background is huge. Instead of pulling each support video in isolation, our CSA module uses self-attention to span across all different shots of the same class. It dynamically clusters high-value features in adjacent frames, forcing the model to capture shared intra-class action patterns and completely ignore varying static backgrounds. Finally, we conducted extensive evaluations on 4 standard benchmarks. As shown in the performance table, our MPL framework achieves outstanding results across the board. Whether using the traditional ResNet 50 or a modern multimodal ClipViet backbone, MPL consistently outperforms previous top methods. Furthermore, our visualizations at the bottom provide clear geometric proof. Compared to previous methods where feature clusters are loose and overlapping, our MPL method produces feature distributions with exceptional intra-class compactness and clear interclass margins. To conclude, our MPL framework effectively bridges the gap between representation, learning, and matching, delivering highly robust and discriminative prototypes for few-shot action recognition. Thank you very much for listening. The QR code for our open source project is at the bottom right, and I would be happy to answer any questions you might have.